The circle C with center T and radius R has equation x squared plus y squared minus 20x minus 16y plus 139 equals 0. Find the coordinates of the center of C. Show that the radius R equals 5. The line L has equation x equals 13 and crosses C at the points P and Q as shown in figure 1. Find the y-coordinate of P and the y-coordinate of Q. Given that to 3 decimal places the angle PTQ is 1.855 radians, find the perimeter of the sector PTQ. So here's all the information and the question in summary form then. So let's have a look at this. First of all, find the center coordinates. So let's work on this equation then, shall we? Here it is here. So let's just drag it down, save us writing it again, and we'll do part A. So here, what have we got then? Write this in standard form. X minus 10 is what we need, isn't it? Half of minus 20 is minus 10 squared, plus y minus, half this is minus 8 squared. Now here we'll get 100, so we need minus 100. Here we'll get 64, so we need a minus 64 to counterbalance that. And we've already got the 139 here as well, of course, equals 0. So we get x minus 10 squared plus y minus 8 squared is equal to 139 take 164 is 25 minus 25. Tap it in a calculator if you need to. Move that over to plus 25 then. So now we can see that the center is none other than 10 and 8. So A center is 10, 8. Part B, find the radius. R is equal to the square root of this value here, 25, which equals 5. And then part C, find the y-coordinates of P and Q. Well, here we're told x equals 13, aren't we, in this part of the problem? If we look at the diagram, x is 13 here. So x equals 13 then, and we need to find out the y values gives in the circle. So put it in here perhaps, or we could put it in here. It'd probably be easier for calculation purposes to put it in here. 13 minus 10 is 3, 3 squared is 9, plus y, I'm going to expand this bracket, y squared minus 16, y plus 64. Bring the 25 over, minus 25 equals 0, doesn't it? Got a quadratic in y. Y squared minus 16y. 64 take 25. Well, actually, 9 take 25 is minus 16. 64 take 16 is 48. Equals 0. So let's just check that then. 13 is 9. Y squared minus 16y plus 64 minus 25. This, I'm going to work it out a different way, is 29. 29. 64 take 25 is 40. 39. 39 plus 9 is 48. Okay. So we can factorize this then. Y and y. 4 12s are 48. And that adds up to 16, doesn't it? Minus and a minus equals 0. So that implies y equals 4 and y equals 12. So the lower value, let's look at the diagram, will be the lower value. Q is 4, P is 12. So P value is 12 and Q value or coordinate is 4. That's part C. Okay, find the perimeter PTQ. So we got this circle. This is a height 12. This is of height 4. So this distance here must be 8, mustn't it? This triangle here is a right angle. This is then 4. This is 5. And this distance must be 3. 3, 4, 5 triangle. Okay, so we've got half base times height. So area, perimeter we need, don't we? So it's a 5, it's an 8, and it's a 5. That's all we need to do. Perimeter PTQ. So that was 5, that was 8. So this distance was 4, as we said, halfway. 4, 5, 3. So all we need to do is add up 5, 5, and 8. I don't know why we need this angle here. Seems rather strange. So answer then for part D. Oh. Let's have a look at the question just to be absolutely sure it's a triangle. Because it might be the actual perimeter here, mightn't it? PTQ as part of the circle, not the triangle here. So I'm just going to flick back to the question. Sector PTQ. Okay, we need the sector. So that's why we needed the angle. So this sector here would be PTQ would be 5 and 5 plus r theta, isn't it, for the arc length? So it will be r times 1.855. That's what we need. So let's just take that then, and we'll move that bit of workings down to our relevant section. And let's just tap it in. Okay, we need to tap that into a calculator then. So it's 10 plus 5 times 1.855. Oh. 10 plus 5 times 1.855 equals decimal 19.275. 19.275. And the required degree of accuracy, it doesn't specify, so we can leave it as that. The units, whether they be centimeters or what's mentioned in the question, of course.